Assalamualaikum warahmatullahi wabarakatuh. Good day to my panel, Madam Sohaila binti Mirin and technologist Dr. Suzana binti Ahmad. Today, I will present my bachelor degree project and my title is Development of Radio Frequency Identification Tracking System in Industry Warehouse using Drone. My name is Muhammad AMIRUL bin Muhammad Nazri and my matrix number is B081810096 and my supervisor's name is Technologist Salihah binti Muhammad Saleh. This is the poster of my overall project. Now is for introduction for my project. So what is RFID? RFID is a radio frequency identification system that is a wireless system comprised of two components, which is readers and tag. Reader device has one or more antennas that emit radio wave and signal received to RFID tags. Tag is used as radio wave to communicate identity and other information to reader. What is drone? Drone is a mini plane that operates automatically or under control remotely by human operator at distance. So, and what is RFID tracking system using drone? RFID tracking system using drone is basically a combination of RFID and drone, where the RFID system, I will attach it to drone so that we can scan any RFID tag from far away. The problem statement of this project is first, industry warehouse or site environment, which is many invention is assistive technology being helpful to industries and warehouse, but still there are some problems with those inventions. Managing the availability of assets that rely on a wide range of instruments is a difficult task to do. And the second is difficulty of searching materials, which is manually searching is an inability to find and allocate items or material in short time. And some of inventions use more time and energy to do such work, such as RGB and barcode. And last but not least, is wastage of time and energy, which is some people feel uncomfortable with this system where excessive movement brings tiredness. And to find material in large industries or warehouse takes more time and energy. This is the project objective for my project. First is to design hardware of tracking system using RFID and drone. Next, to develop an algorithm software program of tracking system by using Arduino. And lastly, to test and analyze the performance of tracking system in terms of accuracy and efficiency of RFID use. This is the work scope of my project. Radio frequency identification system is designed to track and detect material or resources. Second, drone will be applied to find material at any specific places in short time and applicable to cover small and large area. Arduino Uno will be applied for the software system, and Proteus and FruitZing software will be applied to simulate circuit. So this is the prototype for project. As you can see, this is the RFID, ESP, and the drone. All is attached to become a one project. So for methodology for this project, this is the flowchart of my project, which is we start from the problem statement, literature study and review on selected components, study on RFID, and we create coding, and then design the circuit and test the system either it works or not. If it doesn't work, then we troubleshoot and do it again. Then if it works, then develop the construction of hardware, testing and troubleshooting, and analyze the product and system. And this is the flowchart for my coding a software system, where we write C++ program in Arduino and compile the program and test whether it can be compiled or not. This is the analysis for my project. This graph shows the time taken to detect by Wi-Fi range of ESP8266. As we can see, the Wi-Fi detect start from 2 meter to 10 meter. At 2 meter range, the Wi-Fi is detected after 4.6 seconds, and in 4 meters, the Wi-Fi will detect in 5 seconds, where at the range of 6 meters from the ESP from the Wi-Fi, the time taken to detect the internet connection is 5.8 seconds, 5.8 seconds. And that's the farthest that we can go for the ESP at 266 to connect with Wi-Fi is 8 meters, which is 8.5 seconds. And with us on the 10 meters range, the Wi-Fi is no longer can be detected. The next analysis is the RFID distance. This graph shows the RFID distance detected from 4 angles, which is from the top, center, left and right. The farther distance that can be detected by using RC522 and ESP. As you can see, the RFID reader can only scan or detect the RFID tag within 2 cm long only, because this is the low frequency RFID system. So the longest RFID system that can detect is from the center, and the left or right is only 0.5 centimeter. Next, the analysis of the weight of load by materials. In this analysis, 4 items have been chosen to be tested as support to attach the RFID and ESP to the drone. After all, materials has been tested, but the drone can only be fully stable by using bamboo stick. As you can see, the bamboo stick is the lightest one between the sponge, trunking and board. So the fourth analysis is which is the Blink application software. Blink application software is used as a monitoring system from the RFID detected. Once the RFID detect the RFID tag, and the ESP will transmit the data from RFID to Blink application, and the Blink application will pop up the output of the RFID tag information. This is the Gantt chart of my project during PSM1 and PSM2. So for the conclusion of this project, radio frequency identification tracking system is a new technology that have many purposes which can be controlled by system. And RFID is used as tracking or detecting material or item. It is easier than manual method or by using barcode technology, because RFID can be tracked from far away better than barcode. It's also will reduce the cost, workers' burden, and reduce time taken to find any material in the warehouse. This is very helpful for industries and warehouse to operate smoothly. RFID is attached to the drone to make it easier to go to any place in the house to track and detect the material. So this is RFID is more efficient and easier to use, unlike manual method or barcode. And this is the references that I've been refers for my literature review in my report project. Hi, so this is my RFID tracking system using drone project. This is the drone and this is my Blink software. So now I'm going to show you my demonstration for this project. First of all, we need to connect the Blink system from the phone to the ESP on the drone. So now I'm going to switch on the ESP. As you can see now, the RFID is on. And from this Blink apps, we can see that the monitor is already online. So the connection between Blink and ESP is already connected. So this is the RFID tag that I will use to put it on any item, and this RFID reader will detect this tag. So when the RFID is scan the tag, and the output data will come out on this Blink app. Now I'm going to show you how to switch on the drone. There's a switch at the bottom of the drone. Then switch on the controller. Now, this is the video that is recorded from H1 Pro software that is connected to drone camera. This is Blink application software, which is to monitor the data output that we get from the RFID input and output. So this software is connected to ASP by using Wi-Fi.